Software Engineering Daily is sponsored by Hired.com. If you're looking for a job, Hired.com is the place to start. I've used it personally and it is an excellent service. Software engineers and designers can get 5 interviews in a week with top companies. Go to hired.com/softwareengineeringdaily for a $4,000 bonus upon accepting a job. Thank you, Hired.com. Elm is a functional programming language for web browsers. Richard Feldman and Srinivas Rao are front-end developers who work with Elm. Richard and Srinivas, welcome to Software Engineering Daily.
Great to be here.
Yeah, thanks.
What is Elm?
Well, like you said, Elm's a functional programming language. It compiles to JavaScript. Essentially, anything you can do in JavaScript, you can do using some combination of Elm or Elm's way of talking to JavaScript, so it's sort of foreign function interface. Basically, you can use it for any kind of web development that you would use normal JavaScript tools for, especially things like React.
What are the problems with web development that Elm is solving?
Rao, you want to take that one?
Sure, happy to take that. So, writing JavaScript is hard. I think we would all agree with that. And one of the problems with JavaScript, particularly, is that the language itself is not great. It's not type checked. It's not functional. It's very easy to have side effects that are unintended. And any front end developer who's been in the industry for any amount of time has probably seen undefined is not a function, or an array isn't an array problems and things like that. Elm solves a lot of those problems. It's just in a way where other frameworks kind of make things better by having a better architecture. Elm makes the language itself better in a lot of ways. Things I don't have to worry about anymore coding in Elm: runtime errors. The amount of times I console log anymore is pretty minimal, and I never have to worry about a thing being a different thing than I would have expected originally. So there's definitely just advantages in writing in a civilized language, and that's what Elm gives us.
The creator of Elm, Evan Czaplicki, wrote a post called "Why I Designed a Front-End Programming Language from Scratch." And the post starts off with this quote: "Today's programming languages have traditionally been created by the tech giants. These languages are made up of millions of lines of code, so the tech giants only invest in incremental, non-breaking changes that address their business concerns." End quote. So I'm curious if you guys agree with this statement, and I'm wondering how you feel it applies to how JavaScript has developed.
Yeah, I would agree with that. It seems like there have been a few exceptions to that. But if you look at the languages that have the most traction, there is an enormous correlation between having the backing of tech giants versus not. I mean, Java's huge. It was backed by Oracle. JavaScript is huge. It was backed by Netscape and other companies that developed browsers afterwards and followed suit. C# obviously is backed by Microsoft, that whole family of languages. Really, I think the only exceptions to that are maybe Ruby, which was, got big basically when DHH came out with Rails. Before that was a big corporate thing. Arguably Python, although Python wasn't really big until Google got behind it. And I think when it comes to JavaScript in particular, it's the intersection of it was backed by Netscape's desire to have some scripting language in the browser, combined with a really short deadline for Brendan Eich being able to ship the thing. And in particular with JavaScript, the idea of the language being created to serve the tech company as opposed to the end users. That's a great example because originally it was just going to be Scheme. It was just going to be Scheme in the browser. We would have had functional programming in the browser from day one. Except that somebody at Netscape, or so I've heard, the story goes, somebody said, this Java thing is pretty popular right now. We want you to make it like Java instead. and that's how we ended up with JavaScript. So,
Evan continues his post by saying, open source language innovation has not yet disrupted front-end programming. We still use the same object-oriented model that took over the industry in the 1980s. The tech giants are heavily committed to this approach. So what are the problems that are associated with this object-oriented programming that is espoused by the tech giants?
Well, Brad, you have a comment on that?
Sure. So, for some context, I think me and Richard were both, down with object-oriented programming in general. Our back end is totally OO, obviously we're Rails. I don't think our worries are specifically around that. But that said, there hasn't been kind of a sea change, or there hasn't been a paradigm shift in front-end development basically ever when it comes to that. We've accepted kind of we've accepted that we're OO because everybody is doing OO everywhere. But those have specific problems on the front end, right? We don't have we have to deal with asynchronous stuff a lot more. We have to do the language and the paradigm is around events regardless, which means that something like the actor model just makes a lot more sense for the problems we're solving. And I think we sometimes fall back on OO kind of as a default. That said, yeah, again, I don't think OO in particular is a problem. Maybe Richard, you're angrier about that.
Well, I would draw an important distinction between OO as it was originally designed by Alan Kay, and OO as Evan put it, the object-oriented model that took over the industry in the 1980s, which was pretty far from what Alan Kay originally designed. Because originally his version of OO was all about immutability and about objects talking to one another, and it was more about organization of where to where your functions should live in regards to the data they're working on, and a lot less about mutation. So when I looked at what I think is problematic about the approach that we've been taking since the 80s, and basically almost the entire time I've been a programmer, the main thing that I think is problematic tends to be mutation and side effects. That seems to be the stuff that gets us into trouble, where we end up with code bases that do surprising things, and we have bugs that are difficult and time-consuming to track down just as a result of doing normal maintenance and expansion of our code base. From my perspective, the overall symptom of what's wrong with front-end development and really programming in general is just that we have to accept the reality that our programs are going to change a lot. We're going to iterate. We're going to want to make improvements. We're going to want to add new features. And if the default is that iterating and adding new features causes bugs, that's a big problem. And we can't be in a normal, in a world where the normal state of things is that when we do the normal thing, it causes problems. That's just a symptom of something fundamentally broken. And what I've seen in my personal experience has been that when you have lots of code with mutation and side effects all over the place versus when you have a code base that has few, or in Elm's case, no mutation and no side effects, the latter is easy to refactor. It's easy to improve upon. It's easier to iterate on, and it doesn't break things when you do those things. So it just makes a lot more sense to me to sort of embrace the reality that our software needs to change and evolve and work in a language that makes it easy to do that.
Right. And so as we get into this discussion of how Elm solves those problems, those anti-patterns that get associated with object-oriented programming somewhat, we should first kind of discuss how Elm is used. So Elm is used to declaratively create user interfaces, or at least that's one of the primary uses. If you sit down, you start messing around in the in-browser experimental playground for Elm, which by the way I recommend to anybody. It's a really easy onboarding process. There's lots of examples online, but I'd like to get an idea for how you define declarative programming and what is the nature of this declarative user interface creation?
So I would say declarative is simply no mutation, no side effects. You look at something like CSS, people can agree that that's declarative. There are no, in CSS, you cannot reassign variables to anything. You cannot mutate anything. You just write it out once, and it's a complete description of what you want your style sheet to do. Elm is the same way, as crazy as that sounds, since Elm has things like if and branching conditionals and it can cause the browser to perform tasks that themselves have side effects or that have effects rather. But at the end of the day, ultimately, when you run your entire Elm program, you can compile the whole thing, and what it's compiling down to is just a set of instructions that you want the browser ultimately to execute. But none of those particular instructions are directly going and telling your computer to do an effect or to reassign a variable or to mutate some data. It's just a list of instructions which then the Elm runtime carries out.
And so this declarative programming is also functional. And I'm curious what you think are the conceptual leaps that programmers have to make to get from procedural programming to functional programming.
Sure, I can take that. So, I think as someone who's come to functional programming relatively recently, I think the biggest jump is that basically smaller transformations are harder. Things like changing a key in a mapping or adding an element to a list are slightly more difficult, just because you can't pull something out, change it, and expect the original thing to have changed, right? And that's a big jump for a lot of us. But the other side of that is larger transformations are much, much easier to reason around in a functional style. And what that means is when I write a giant function that takes in a model and returns a new model, I never have to worry about things changing that I never expected to. So at least for me, that's the big jump between procedural and a functional style. But I don't know, maybe Richard has a better sense.
Yeah, I would agree with that.
Okay, well, so let's get into the even further into the buzzword bingo type of categorization. Actually, that's a bad way of putting it, but there's a very so it's a very legitimate paradigm shift to this thing called functional reactive programming, and there's some discussion around how this is defined. But what are each of your subjective definitions for what functional reactive programming is?
I have no idea. I don't know, and I very much don't care. So I've actually talked with Evan about this, and it's funny because initially the way that Elm came about was simply that Evan wanted to solve a problem. He just observed that developing in JavaScript was more difficult than was reasonable, and he wanted to solve that problem by creating a language. And so he did a bunch of research into what was out there, and some of his research included papers, academic papers, and research and things like that on things that self-identified as functional reactive programming. And so when he incorporated a lot of those ideas into Elm, he said, "Oh, well, okay, Elm is also functional reactive programming because I've done that as part of I have used these concepts from these papers that call themselves that." And then later on, some people started saying, "Well, Elm is not truly FRP for these reasons." And Evan pretty quickly said, "Okay, I don't care. Mainly, the thing that I care about is that Elm is a nice language that solves these problems, that makes front end development, pleasant and scalable." And I would agree with that. So I have never looked into what the different definitions of FRP are enough to really know. And honestly, it doesn't really impact my life much. Mainly, what I care about is that Elm is nice.
So Rao, do you agree with this, or so one of the things I hear about with functional reactive programming is time is really important, and so you have this constant notion of your code describes how things are at any given state, and so hand in hand with this is the notion that time is constantly passing, and therefore time is sort of this mutative parameter that's being passed through your code. I don't know, Rao, do you see that as an accurate description?
Well, so yes and no. So let me answer that in two different ways. One is that kind of when you're coding in Elm just day to day, very little of your life is spent dealing with the functional reactive aspects of it, and those are implemented as signals in Elm, and the pure JavaScript implementation of that is like people use Bacon.js, which is basically like event-driven state updates, and you don't deal with that. And I don't understand people who who say their entire jobs are dealing with stuff like that, because at least my job hasn't been. But specifically, you're right. Like, time is a much harder thing to work with in Elm than it is in traditional JavaScript, because time changes, right? It's mutation. It would make functions non-pure if you were asking if a thing is asking what right now is different in 10 minutes than it is now. But and there are likely other things that are harder in a functional paradigm that aren't in a procedural paradigm. That said, we never deal with that. We just kind of step by those questions like that. Like, for instance, anytime we do need to ask what time it is, we just set what time it is before the program starts, and we just use that as a constant. I mean, Richard, can you think of anything else that are harder because of time passage? I can't think of an actual bug that's caused on the site.
Yeah, no, I mean, so it's certainly true that Elm is built on top of signals, and it's certainly true that FRP is based around those ideas. But at the end of the day, it's really just kind of the foundation that that's like Rao said. That's just really, FRP is not really the stuff that we spend our time on. The stuff that we spend our time on is the same stuff that JavaScript programmers spend their time on, which is to say building out UIs, setting up event listeners for user input, describing how business logic reacts to that, and how the UI should update in response to user inputs and things like that, sending data to the server. When at the end of the day, time is I wouldn't say any more of a large thing that we spend time thinking about in Elm than it was when we did React and Flux before it. It's just that Elm is built on these different primitives than React and Flux are built on, whereas React and Flux are built on mutation. Elm is built on this idea of signals that ultimately accomplish the same thing, but the fact that that's the foundation is not really all that relevant to our day-to-day experience of using it. Just in this.
Okay, well, give me a better idea of what a signal is.
The definition of a signal is it's a value that changes over time. So basically the rule of a signal is that you have to be able to look at it at a particular point in time and say, what is your value at this exact moment in time? And it has to give you back exactly one value for that.
Okay, and can you give me an example of how it's used in practice? What would be a signal?
Sure. So, as Rao noted, the current time, I guess, is kind of a tautological example.
You can't use that one now.
Yeah. Okay. So, a better example would be maybe, let's see, I'm trying to think of one that we actually use other than ports. Ports are pretty much by far the most common
number
one.
of likes, maybe if you're implementing a Facebook page.
Oh no, I mean, well, if we were doing something like a Facebook page, we wouldn't use signals at all. I mean, the reason I'm struggling to answer this question is because we really don't use signals on a day-to-day basis. I'm having to dig through my memory of okay, so I remember at some point I was thinking about designing an API for the full screen. So when the user enters full screen mode in the browser, in JavaScript, that's set up as event system. So you would subscribe to the event, you would add an event listener for when the user changes full screen state or not, and then run some code depending on when they do. In Elm, the way you would do that is you would probably set up a signal, which is just a signal of Booleans for whether or not the user is in the full screen state. So at a given moment, you could ask that signal, is the user full screen right now? Yes or no? And as over time, as the program continues running, it's going to accumulate. At this moment it's false. At this moment it's false. At this moment it's false. And finally, the user enters full screen mode, and now it changes to true, and then it stays true until they exit full screen mode again. And so, because of the way Elm is architected, you could write your UI in terms of that, and basically instead of adding an event listener imperatively, you would instead basically listen for changes to that signal, because that amounts to the same thing. It's just a different way of describing it.
Is it like a watcher?
In that example, you could kind of think of it that way, but
okay. Sure. Okay. Well, let's discuss the Elm architecture, which is the basic pattern for which all Elm programs are written. So, Richard, could you give me a high-level description of the Elm architecture?
Sure. You have three components or three pieces to it: your model, your view function, and your update. So essentially, you have a model, which is just a bunch of immutable data that represents your entire application state. You have your view, which takes that model and translates it into what you want the screen to look like, what you want the interface to look like. And then you have your update, and your update function takes a model and an action, which is a description of how you want that model to change, and then applies that action to the model in order to give you back a new model. So the cycle that happens there is when the user, so the view function takes the model and renders the view. And as part of rendering that view, it also describes when users give various inputs, such as clicking on things or pressing keys on the keyboard, things like that, drag and drop, what have you. When the users make certain inputs happen, then those inputs get translated into actions. And then those actions get fed into the update function along with the current model in order to translate it into a new model, at which point you take the new model and it gets the view function gets called again with the new model and re-renders everything. And much like with React and all sorts of other nice virtual DOM implementations, the view function is returning a virtual DOM, which is just a representation of how you want the screen to look. And Elm under the hood will take care of diffing that with the previous representation and very efficiently coming up with the minimal set of actual DOM updates necessary to make that change happen and applying them to the screen. So you're just essentially working declaratively with your model, your update function, and your view function, and the Elm runtime is taking care of the rest.
Let's talk about that in more detail. How does the Elm architecture compare to the classic model view controller strategy?
Brad, you want to take that?
Yeah, sure. Happy to take a shot at that. I mean, so there's like the classic MVC, there's like Rails MVC, and what front end has come to term like MV whatever, right? And I think anyone who's had any experience with other front end frameworks who have models and views, or in React parlance like components and stores, will the jump is pretty similar. There's like state in one place and mutation and like how to transform state in one place and the store in the model, and then the view handles the view or the component handles the actual rendering of that thing. And then in React, there's like a dispatcher that stays in the middle. In other systems, there's a controller that stays in the middle. But in kind of big picture, the separation is very, very similar to something like to other frameworks and to what we would think of as MVC. I mean, the big difference obviously is that like it's all functional. So the model doesn't actually have like run transformations on itself. The model is just a bucket of functions that take in a record or like basically a big piece of state and return a new thing that has one or two attributes changed. So the model itself doesn't store state. It's just a series of functions that transform state.
Okay, and Richard, as I understand, you've done a fair amount of work moving a application from some previous architecture to using Elm, and I'm curious what that transformative process has been like.
So I would say that it depends on what architecture you're coming from. So I did it once with a side project of mine called DreamWriter, and then I did it on a very small scale at NoRedInk, which is where Rao and I work. And by the way, we're hiring. And and we so with DreamWriter, I started with React and Flux and essentially ported the whole thing over to the Elm architecture. That was not a big shift because mainly the change was making the language jump. It wasn't so much an architectural paradigm shift, really. As it happened, I only had one Flux store. So essentially, if you've only got one Flux store, then mapping that to an update function is pretty mechanical. It doesn't take a whole lot of changes because you're essentially starting with, instead of your action dispatcher and your Flux store, you're sort of rolling those together into one update function, which is just starting with a model and an action and giving you back a new model, which is exactly what an action dispatcher and store in Flux will do. You take in an action and then you end up with a new sort of model in the sense that you have a new store state at the end of the day. So that was not a big deal. At NoRedInk, it was even smaller than that because it was literally just rewriting one Flux store. So I guess when we introduced it at NoRedInk, it wasn't so much of a introducing the Elm architecture right off the bat. It was more just rewriting one small Flux store in Elm. And then once we determined that this was something that we liked and that we wanted to start using more, then we started using the Elm architecture from scratch on all of our new UIs that were built out for new features.
Wow. So you're planning to really build out the aspect or flesh out more of your architecture in Elm going forward.
Oh yeah. I mean, all of our new stuff's in Elm. I mean,
it's been probably 3 months of just every new thing is Elm.
Oh yeah.
If not more.
Yeah.
How has that improved developer productivity, or in what ways has that changed how you write applications?
Well, I think it's definitely so the speed at which we're writing new features has probably slowed down a little, just because when we first started doing Elm, Richard was the only one who had any experience in it. The only anyone knows who had experience in functional programming at all. And now there's probably 5 of us who do functional programming in Elm. So the initial jump was definitely a little slower. But that said, we have a lot fewer bugs, and it's much, much easier to change things. So it pays for itself almost immediately, because we will have a feature, then have 10 spec changes, and those spec changes, instead of taking 2 days each, will take an hour or 2, and we just know the code works.
Why is that? How do you get those huge speed gains?
So at least from my perspective, the big thing is in what we were in React before, and I think a big problem with any front-end code, or really any code base that has mutations in general, is that if I change something, I'm not sure if it will still work at runtime. So if I change a variable that used to be a Boolean to an array, in a React code base, I'd have to try every single component that might use that value to see if it will if it'll still work the way I expect it to. Because React code will compile even if you give it bad parameters. In Elm, you have a compiler and a great compiler at that. So if I change an attribute or change how something is stored, I'll immediately know everywhere in the code base where I need to update. So the result is it's very quick to change things, and you have a lot more freedom to be flexible about that stuff, because you just know that the compiler has your back the entire time.
We'd like to take a moment to thank our sponsor. DigitalOcean offers simple cloud infrastructure for developers. In one click, you can have a mean stack, a Rails application, an Ubuntu box, or another custom environment. Software Engineering Daily is proud to have DigitalOcean as a sponsor because DigitalOcean is the simplest cloud service provider. I've interviewed Moisey Aretsky, who is a founder of DigitalOcean, and he told me that DigitalOcean was based on this realization that other cloud service providers are so complicated. If you want things to be simple when you deploy your application, use DigitalOcean. To try DigitalOcean, go to DigitalOcean.com and enter promo code SEDaily. That promo code is one word, SEDaily. Now let's get back to our show. I'd love for a more in-depth discussion about Elm versus React. What are the most important points of comparison when you're looking at Elm versus React?
I would say the most important one is the compiler. So you can, if you want, use React with the Elm architecture and immutability, and you can choose not to use side effects anywhere. So what that would basically look like is, so Redux is essentially an implementation of the Elm architecture for React. So you could use that. You could use an immutables library like immutable.js or seamless immutable or any of the others. You could use essentially actions in a style where you're deliberately not doing side effects anywhere, and using discipline makes sure that you're only using side effects in you're in one place, so they operate more like managed effects than side effects. The problem is, even if you do all of those things, you don't have guarantees around them. You're just benefiting from them to the extent that you are successful at maintaining your own discipline. So the problem with that is that we're human and we make mistakes. We try to stick to something, but we inadvertently fail to from time to time. It's just inevitable. And with Elm, you not only are doing all of those things, but the compiler is guaranteeing that you're never breaking those invariants. So, for example, if you look at any given function in Elm, and it says it returns a string, you know for sure that several things. One, that it returns a string always. Two, that it's not mutating any other part of your program. Three, that it has no side effects, because the only way anything in Elm can do any effect is if it returns a task, which is kind of like a promise, instead of some bare data type like a string or a record or a list or something like that. So just right off the bat, you eliminate this huge class of errors just by looking at the return type of any given function. And as Rao mentioned, the compiler guarantees that. You can't mess that up. If you say that it's returning a string, or for example, if you have several different pathways with branching ifs and things like that and calling other functions, if sometimes it returns a string and sometimes it returns a task, the compiler won't let you do that. It says, no, you need to always return one or the other. You have to be consistent. Also, there's no concept of null or undefined or nil or anything like that in Elm. Instead of the absence of a value being something that can sort of permeate through your program and lead to undefined is not a function and things like that, instead it's opt-in. You have to specifically say when a value might be missing, and you can't forget to handle it. So that's basically why we don't really see runtime exceptions anymore, because our Elm code is backed by the Elm compiler, and it just catches all of that stuff ahead of time.
Yeah, I'd add, especially like specific on that point, like in React, you're constantly refreshing the browser to see if like things are still working. And there are entire days where I don't even look at the browser when I'm coding in Elm code because I just know it's going to work, which is like, pretty amazing.
Interesting. Do you guys know any in-depth details for how the Elm compiler works?
Crazy magic. What do you want to know? I know.
Well, I mean, how hard is it to write a fast in-browser compiler?
So the compiler doesn't run in the browser. I mean, it runs in the command line.
Okay.
Yeah. I know that it depends on how nice you want to make it. So Evan has invested a ton of time in not only making sure that it works properly and works really fast, both of which it does, but also in just giving really nice error messages when things go wrong. To me, that's a huge difference, because I originally, way back in the day, was a Java programmer, like an enterprise Java developer, and hope never to go back to that world. But
me neither.
I had a very different impression of compilers back then, because in Java, you have a compiler that is slow and honestly not very helpful and only catches some errors. I feel like Elm's compiler is lightning fast. It essentially catches almost all errors that I could reasonably expect a compiler to catch, other than like logic errors where I just wrote something that was sane but wrong. And when there's an error message, it tends to give me something helpful that points me in the right direction. And that's also improving all the time. I'm particularly excited about the next release of Elm because it's got even more crazy improvements to the niceness of error messages and basically decreasing as much as possible the amount of time between when you make a mistake and how quickly you can fix it. So to answer the original question, I don't know how hard it is to make one of these compilers because I've never made one, but I can say that I know that Evan is one of the foremost experts in this field, and he has, despite that, spent an inordinate amount of time making the Elm compiler as good as it is. So I don't think that we'll be seeing another compiler of this quality anytime soon from any other languages.
Yeah, okay. So, you've mentioned the value of the Elm compiler in terms of the error messages it gives you. I'm curious about the other types of tools that are available for debugging and testing Elm code.
So there are two main other ones. One is called Elm Reactor, also known as the time traveling debugger. Honestly, we don't really use that. It's pretty cool. It makes for a nice demo, but it's at least not at present. It's not really solving a problem that we have. There's a work in progress for a future version. So essentially, the cool demo that it gives is you can run your program and then you can pause time, rewind time, and just watch what you just saw replay in reverse. And then after going back in time, you can modify your code and change some of your logic, and then hit play again, and it'll replay all of those actions except with the new code applied. So the use case for this would be you're going along and you encounter a bug, you hit pause, you rewind so that you can now watch the bug get reproduced, and then you change your code and fix the bug, and you can hit play again and watch to confirm whether your change actually fixed the bug without having to manually click through and reproduce the state and all that. What's really exciting about that, though, is the idea of being able to export and then import those replays. Because something that we do spend a lot of time on, and a problem that we would love to have solved, is reproducing stuff that other people find. Specifically, we have a QA guy who, every time we're about to make a release, he will go through and check it and make sure that it's good. When he finds a bug, currently the state of the art is he reproduces it himself to make sure that it is reproducible, and then he writes out a description of how to reproduce it, which we then read and then attempt to reproduce it locally. There's a lot of time wasted in that reproduction process. It would be way better if we could just have him running Elm Reactor, and then once he hits a bug, he just hits pause, exports it, sends it to us, we import it, and then now we have the exact test case that he came up with. Not to mention, not only can we do it for our local development, but in theory, once we have that in a data form, we could also use it to write an automatic integration test to make sure that no longer reproduces going forward as part of our test suite. So that would be awesome, but that's not out yet. I know the guy who's working on that, but he's not done with it yet. So that's one tool is Elm Reactor. The other tool is Elm Test, which essentially runs on Node.js and just runs unit tests against your Elm code. So we use that for testing things like validation logic, just general business logic. In some cases, we use that in conjunction with Elm Check, which is sort of a property-based testing tool, so, like Quick Check, where it generates a bunch of random data according to your specifications and runs your tests like 100 times with a bunch of different random inputs so you can assert various properties about the results. So from my perspective, those would be the two main tools for that.
And I'd love to get some more color on the culture around open source on the Elm project. Like, how many people are working on Elm-related projects, and how is the culture growing?
Well, I don't know exact numbers as far as the, how many people are using it, but it's definitely growing quickly. I think like a year ago, I remember being on the Elm Discuss mailing list, and we would see a couple of posts every day, and that the same kind of handful of people on it. But now I just can't keep track of it. There's just too many new people all the time posting stuff and asking questions and getting impressively detailed answers. So I haven't really done any measurement, but one metric is that basically Evan has been unable to keep up with the mailing list anymore because the volume is too high. Where he used to sort of, respond individually to people. Now he's like, I just can't. I'll be spending all day on this if I if I keep monitoring it. So now he's kind of like delegating it and trusting that some of the older community members will ping him if something important comes up, and so that it doesn't escape his attention. But so there's that. There's now, several companies using it in production. There's us, Circuit Hub, Future Ice. Periodically we hear companies tweet about it that they've shipped some Elm production thing, and we're like, who are you? We never even heard of you. And so it's definitely growing. It's growing quickly, and I'm really excited to be one of the companies on the forefront of this stuff.
Give me a better idea of how Elm interacts with traditional web technologies like HTML and CSS and JavaScript.
Sure. I think Elm to CSS it's the exact same to HTML, CSS, or JavaScript to CSS, right? It's a totally separate thing. It also has no, maybe our ops guy wouldn't agree with this, but it has no bearing on our back end at all. The only interop we ever have to do is Elm to JavaScript, and Elm has a pretty nice interface for this called ports, where basically you can call out to whatever JavaScript library you want. For instance, we use an old jQuery date picker that we want to keep on the site. Well, maybe want to keep on the site. But we are keeping on the site.
We do.
Obviously, we can't ensure that it doesn't have mutative side effects. So Elm lets you kind of put JavaScript code, arbitrary JavaScript code, in containers where Elm is basically okay, it's cool that you're cool with this piece of code, and you're cool if it causes mutations, and we have to say yes. So there are certain parts where we have these ports to things, but most of the time we're just writing Elm, and the interop stuff is very simple or mostly just a boilerplate. But yeah, to HTML, it's not like Ember or Angular where you're writing half HTML, half JavaScript templates. In Elm, you write your HTML through Elm helper functions. It looks a little bit like React code minus JSX. So you have a helper called div that takes an attribute called class. But it's fairly straightforward. Our designer has actually started looking at it. It's not crazy. It has the same structure as HTML. It just isn't organized. It just doesn't have the same syntax. But yeah, in general, it feels a lot like JavaScript development.
Right. Okay. So if I have some experience with JavaScript or just with Rails, how do I get started with Elm?
So we have a blog post about that, actually. It's called Building a Live Validated Signup Form in Elm. And essentially, it literally just assumes that you know JavaScript, and that's it. It doesn't assume any knowledge of any functional programming or any Elm knowledge whatsoever, and it just takes you through start to finish, from getting started to building things to extending it, etc., making a sign-up form with live AJAX validation and things like that.
Okay.
That's on our company blog.
Sure. Rao, do you have any suggestions? Because I think you probably started programming Elm more recently.
Well, I'd suggest having Richard at your beck and call for me. But I would say, if you're familiar with React or Ember or Angular, the conceptual jump just isn't that much. It's not that big of a deal. The syntax is a little bit hard to get through, but given a week, it wouldn't be. It wasn't that big of a deal either. For context, my very first day writing Elm to writing my big feature in Elm was probably a month of time. And now I feel totally comfortable, probably 3 or 4 months in. I feel totally comfortable with the language now. So I don't think the jump is particularly huge. And if you're coming from organized JavaScript that isn't just jQuery soup on the page, then you'll have no trouble kind of getting the Elm architecture down.
How does the concurrency support in Elm compare to writing something that looks like concurrency in JavaScript?
Well, I mean, JavaScript's single-threaded, so you can't really get any,
Sure, yeah.
Do you mean like asynchronous things? Like
Yes, asynchronicity.
Oh, sure. You want to talk about that, Rao?
Sure. So, as Richard talks about, the way you manage like side effects in Elm is that they're not side effects; they're called effects or tasks. And basically, when you want to make a request to the server, you say, "I'm going to dispatch this. I'll dispatch this task, and when that task succeeds, I'll set another action onto my into my update function and generate a new model." So, like, kind of it's not any different than handling an AJAX request in a Flux app or something like that, where you say, "All right, I'm going to make this request. I'm going to make this request. Have this task fire off, and at some point in the future, that task will succeed, and will update my model." So, I mean, I don't think we ever really worry about it's just an easy mental model to wrap your head around when it comes to AJAX requests specifically.
What kinds of standard libraries does Elm offer?
So Elm ships with a core library that's, I would say, fairly similar to like underscore or Lodash or any of the variants thereof, except that it's sort of tailored around Elm and the niceties that Elm syntax provides. So you have things like lists and arrays and dictionaries and sets and fun stuff like that, and lots of helper functions to make them nicer to use. There's also sort of a community standard around extending that, where you'll have something like Elm List Extra, which has sort of even more list functions on top of that, or Elm Task Extra if you want some extra task stuff, things like that. And those are sort of like little micro versions of something like underscore or Lodash. So the standard libraries basically give you sort of everything you need to build a basic app and get up and running. And then if you want to do something fancier, there's this whole community of libraries out there that you can use as well. One of the cool things about Elm's package manager is that it guarantees semantic versioning. So essentially, if you try to make a breaking API change to a package you're going to publish to the repository, and you don't bump the major version number, the package repository will automatically reject it and say, this is a breaking change, this is going to break someone's code, you need to bump the major version number. Which makes it, from our perspective, a lot easier to trust that when we're upgrading our packages, that we're not going to have any surprises. And even if there would be surprises, the package tool also lets you run a diff. So you can say Elm package diff, and you give it 2 version numbers and the name of the package, and it will just show you what changed between those two. It'll say okay, this thing was added, this function changed from taking this and returning that to taking this thing and returning that other thing, etc. So the getting libraries from the community is a much nicer experience in Elm than it has been with NPM or Bower, things like that.
Sure. What's the future of Elm?
It replaces JavaScript? No. Wouldn't that be nice?
Well, you joke, but there's a grain of truth in every joke.
Yeah, we'll see. The main thing that's on the future of Elm from a big picture perspective is Elm on Node. So you can actually start writing things on the server. Definitely there's a much greater sense of urgency around Elm for the browser, because there are a lot of solutions you can turn to on the server and way fewer on the browser. So although Elm's paradigm is perfectly well suited for server-side development as well, there's just a much greater focus right now on the browser, and pretty much the only Elm thing that runs on Node is Elm Test, because you want it to run from the console rather than having to bring up a browser just to run your unit tests. But other than that, there really hasn't been anything released or any libraries released for writing Elm code on the server side, even though conceptually there's no reason you couldn't do it right now.
Yeah, I'd add to that like, I don't know like what the future of Elm is, but it does seem like the future of other front-end tools is Elm, if that makes any sense. Like versions of, like the new tooling around React, for instance, Redux, like both like that seems a lot like the Elm architecture, or like stateless components is a thing that Elm has been doing, and React is like getting closer to. Ember is like went from something closer to the Angular model to closer to the React model, and React is getting closer to the Elm model. Kind of this notion of having state in a single place where it's easy to manage and all transformations on it are pure, like seems like where front-end development is going altogether. Whether that's an Elm or not, I don't know, but I think Elm is kind of on the right track.
Well, what I find curious about that development is it seems like it's this sort of like mental convergence of the developer community on that model, and it's not like led by anybody specifically, but it's interesting because like it seems like the minds are converging on this idea, and I don't know, are there some underlying factors that are driving that?
Honestly, I think it's mainly just that we've had a lot of pain points for years and years in front end, and people have tried a lot of solutions, and these are the first set of solutions where people are actually feeling like it's solving the problem. I think that, historically, if we had a bunch of different attempts at a bunch of different MVC frameworks, but ultimately at the end of the day, the reason that people were saying like, oh, should I be using Angular? Should I be using Ember? Should I be using Knockout? Should I be using, there were a million different flavors of MVC. And I think the reason there was never a clear winner is just because MVC wasn't solving the problem. I mean, it was making some things easier, but fundamentally there was still this big problem. And I think the next evolution of that is that people are saying, okay, wow, this virtual DOM idea is really good. And the reason that everybody's going from Angular to React or from Ember to React, or, everybody is going to React, is just that virtual DOM is just, a good solution to these problems. And I think that now we're pretty clearly seeing the same kind of thing happen where people were saying, okay, Flux, that seems like a better idea than what we had before. But pretty quickly, now people are saying, okay, well, wait a minute. Actually, Flux solves a bunch of these problems, but it's kind of a stepping stone. What is it a stepping stone towards? And the answer is sort of a single state atom, which is why people are starting to talk about, okay, I think actually Redux is where we want to end up. And especially when you have a single state atom, there are these concrete benefits, like you can have a time traveling debugger, which Redux has as well. It's not just Elm that has that anymore, because what you need for that is a single state atom, as opposed to state scattered around your application, and with each component being, the owner of its own state. And now that we're starting to see this convergence on that, and people are starting to say, well, this has concrete benefits to organizing things this way, I think the next logical step is going to be, okay, what if I already have all of these things, if I'm already organizing my JavaScript this way, why am I not using Elm, which takes this a step further and says, sort of the cost of Elm, if there is a cost primarily, is that you have to do all of these things. You have no choice but to have a single state atom and to have immutability everywhere and to have no side effects. But if you've already concluded that you don't want to have those things, then that cost kind of goes away. And at that point, it's just like, well, what do I have to learn? I have to learn some syntax, I guess. And then the benefits you get are no more runtime exceptions, which I think, and my experience has been, is kind of a big deal, and that JavaScript will never, ever have.
Oh, well, I think there's also a similar march toward functional programming. Like, I think people who are into functional programming also talk about it as though, like, this is just like the long arc of history is bending toward functional programming. And that started years before we were developers and will continue years after us. And I think like it's happening on the front end faster, but we're seeing that movement everywhere. And I think Elm is just another one of the another language that's great that people are turning to because of its functional style.
I just got to shout out, that was an excellent MLK reference. Drafted on functional programming. Well done.
Cool. Well, that sounds like a good place to stop. Richard and Rao, thanks for coming out to Software Engineering Daily and giving us an overview of Elm. It's been Really nice talking to you guys.
Yeah, thanks for having us.
Yeah, thanks.